Good morning. So, our lesson today is about parallel perpendiculars and distance. So, if you notice, we are jumping into 3-6 because the lesson today will deals with equations of lines. And so, since we had the equation of the line yesterday, might as well continue on with this lesson. And then tomorrow, we'll have 3-5. Okay? So perpendiculars and distance. This talks about the distance from a point to a line. Okay, so if you're asked what is the distance from a point to a line, that means if you connect a point to a line here, for example here, if you're going to connect this point C to line AB, you would connect them in different ways. You can connect this C to a line. I mean, you draw a line closer, all the way closer to A, or you can draw a line closer to B, or over here. And so with these broken lines, it's very obvious that when you measure each of these broken lines, they will have different measurements. But if you ask what is the distance between this point and this line, there must be just one answer for that. Okay, so we cannot say, oh, teacher, I found it's the 2 centimeters, and that teacher, how come my answer is 3 centimeters? How come my answer is 5 centimeters? So we'll have different answer if we don't follow the concept in finding the distance between a point and a line. So to find the distance between a point and the line is to find the shortest possible distance that you can have between a point and the line, and that can only be attained if the line that connects the point and the other line is perpendicular to that line. Okay, so since it forms a right angle here, then we can say that the solid line connecting point C to line AB at this point is perpendicular to this line. And so therefore, whatever is the measurement of this, that's the distance between this point and this line, not the measurement of this broken line or this broken line or this broken line. Okay, it should be the perpendicular line. That's why you notice when you go to the crosswalk, okay, in the street, what can you notice about our crosswalks? It's perpendicular to the side. Okay, your crosswalks are not created like diagonally, because the shortest way to reach the other side is to cross through the crosswalk, which is perpendicular to the side of the road, or that's the shortest distance possible for you to move from one side of the road to the other side of the road. Okay, so when you cross the street, you have to cross in a straight line and not on a diagonal line, or else you're staying a long time on the street and you can be prone to accident. Same thing with parallel lines. When two lines are parallel, okay, to find the distance between two parallel lines is to construct also a perpendicular line between them. Okay, so for example, from this line to the next line, from this line on top to the line at the bottom, since these two are parallel lines, to find the distance between them, we can draw a line from A to K, making sure it's perpendicular. You can have a line from point C to point H, and they're perpendicular. All of these lines that are perpendicular to both parallel lines are equal. So whether you measure it on this side, you measure it on this side, as long as the line that connects the two lines are perpendicular, then their distances are the same, because again, the two lines are parallel. So whichever point you start to draw a line on your first line, make sure it goes to the other line and it forms a right angle on that line. And then that is enough to identify the measure between two parallel lines. So it's called equidistant. Okay, so two lines in a plane are parallel if they are everywhere equidistant. So if they are everywhere equidistant. Now let's focus on this lesson here, finding the distance between lines. So you will be given with two equations. So find the distance between the parallel lines L and N with equations y equals -1/3 x minus 3 and y equals negative 1/3 x plus 3 respectively. So let's verify if these lines are parallel, because we can only find the distance between lines. There is a unique distance between lines that are only parallel, because if the lines are not parallel, you cannot have a certain distance, or you cannot have that distinct distance that separates the two lines, because at some point they're gonna meet. At some point your distance are changing. So it's only applicable for parallel lines. So to verify if they're parallel lines, we look at the two equations. This is y equals negative 1/3 x, just y on one side. That means this is an equation in slope-intercept form. Y equals negative 1/3 x plus 1/3, just y on one side. So this equation is in slope-intercept form, and that means the number beside the x is the slope of the line. So the number beside the x here is negative 1/3. The number beside the x of the second equation is also negative 1/3. Then that means the two slopes are the same. And if the slopes are the same, then these two lines are parallel. Now, so there is a graph over here that will serve as our guide. You see, this is the graph of line L. This is the graph of line N. Okay. So first is we need to write an equation of line P. What is line P? We need to make an equation for this third line P that is perpendicular to both lines. Okay. So it's perpendicular to L and N. Since they're perpendicular, the slope of this line is related to the slope of the original line that we're given with. So since the slope of P is opposite reciprocal of 1/3, because the slope of L and N is 1/3, negative 1/3, therefore the slope of P is opposite reciprocal of it. And therefore, opposite reciprocal of 1/3 is 3. So we're going to use this and the other point that we can see on the line. Okay, so in line L, we're given with an equation negative 1/3 x minus 3. That means this is the slope, negative 1/3 is the slope, negative 3 is the y-intercept. If you graph that one, the y-intercept is the point where the line crosses the y-axis. And so the graph tells us that it's on 0, negative 3. So looking at the equation itself, you can identify one point, the slope of the equation, and another point of the equation, which is the y-intercept. So y-intercept is an ordered pair wherein your x is 0 and your y coordinate is the given y-intercept. So that's why it's 0, negative 3. So therefore, instead of looking for any points on line L, we just need to use this point that we can see in the equation, so that we don't need to solve for this point, what is the ordered pair over here, or what's the ordered pair over here. Okay? Anyways, you can do that one, but it will take you a longer process. Okay? You might as well just use what is given. So we're gonna cross line P to this point L, and we'll make an equation of line P that is perpendicular to line L. So since L has a slope of negative 1/3, therefore the slope of P is 3. And since the point on the L, which is 0, negative 3, is also a point of line P, therefore that will be our x1 and y1. Or since this is the y-intercept, then you can just write the equation as y equals from here m is 3, and then since your x is 0, automatically this is your b. So it's the same thing as y equals 3x minus 3. So the only difference between your first equation and your second equation, you see, our first equation y equals negative 1 over 3x, 1/3 x, negative 1/3 x, So that is negative 1 over 3. And then negative 1/3 x minus 3. That's the first equation. Okay. So now, when you look at the first equation, our third equation is our third equation looks almost the same with that first equation because the only difference is that their slope. You see? To come up with the third equation, which is for line P, we simply change the slope of our first equation into its opposite reciprocal, and that will be the slope of our third equation. So y equals 3x minus 3. And then we're gonna combine these two equations after identifying the third equation. After identifying the third equation, we will now combine these two equations using systems of linear equation here. Okay, so you will see that one. And then it gives you the value of the x and the value of the y. Now, take note that our first point, our first two equation intersects at 0, 3. This is the common point between line L and line P. So this is your first point of intersection here. This process is the process that will help us identify the ordered pair over here because we need 2 points to solve for the distance between these two parallel lines. Okay, so we have here the solution in finding the intersection of these 2 points. So we have that one, and then it ends up at x equals 1 and y equals 0. And so the point of intersection of your second line or line N and line P is at 1, 0. Okay, so after having these 2 points, after having this point, we will be using this point, this 1, 0 together with 0, negative 3, together with 0, negative 3, and find the distance and use the distance formula in finding the distance between these two parallel lines. So go back to distance formula, x2 minus x1 squared plus y2 minus y1 squared. And so that gives us 0 minus 1 squared plus negative 3 minus 0 squared. Okay, so here the x2 and the y2 is the 0, negative 3. The x1 and the y1 is 1, 0. Okay, and then it gives us square root of 10. Okay, now I'm going to show you a different example here. Okay, let's copy that one. I'm going to solve for the distance between equation x plus 3y equals 6 and x plus 3y equals negative 14. Okay, so we have here x plus 3y equals 6 and x plus 3y equals 14. So take note that these equations are not yet in slope-intercept form. So we have to write them in slope-intercept form. Slope-intercept form is meaning only variable y on the left side. So that gives us what? 3y equals, transfer x to the other side, negative x plus 6. This one, 3y equals negative x minus 14. Divide 3, divide 3, divide 3. Y is equals to negative 1/3 x plus 2. Divide 3, divide 3, divide 3. Y equals negative 1/3 x minus 14 over 3. So now our equation 1 is y equals negative 1/3 x plus 2. Equation 2 is y equals negative 1/3 x minus 14 over 3. Okay, again, first step. Okay, we're going to write the equation number 3. So the slopes between these two lines is negative 1/3. Therefore, the perpendicular slope of that will be, which we're going to use in the line 3, is equal to positive 3. Okay, the ordered pair, the equation tells us that this line has a y-intercept of positive 2. So we use the same y-intercept over here, there. So since this is 0, automatically this is your b. Negative positive 2 is your b. So using y equals mx plus b, your line 3 is equal to y equals 3x plus 2. So this is your line 3 equation. If you look at the difference between line 1 equation and this, the only difference is this y, this slope. And how to get the slope of the other equation is that it's just the opposite reciprocal of this. So y equals opposite reciprocal 3x plus 2, the same thing. Okay. So this is also 0, 2 is also the first intersection of the line. So this is the intersection of the first line, line 1 and line 3. Okay, our task is to get the intersection of line 2 and line 3. So what we're going to do is we say y2 equals y3. So this is y2. This is y3, equation 3. So equation 2 is negative 1/3 x minus 14 over 3 is equals to 3x plus 2. Okay, so we have a denominator of 3. So since there's a denominator of 3, what we're going to do is to get rid of that denominator. Get rid of that denominator by multiplying both sides with 3. So that gives us negative x minus 14, because cross out when you multiply here and then you multiply it there, it's over 3, it's cross out again. Here 3 times 3x is 9x, 3 times 2 is 6. Then minus 9x plus 14 plus 14. So you have negative 10x is equals to 20. Divide by negative 10, divide by negative 10. So x is equals to negative 2. So this is your x. Now we're going to solve for the y, which is by replacing the x of your second or your third equation. Okay, so might as well just use the third equation because there's no fraction. So it becomes y equals, over here, y equals 3x plus 2 equals 3 times negative 2 plus 2, negative 6 plus 2. So y is equal to 4. So that means our second intersection is at 2, is at negative 2, 4. Okay, so now the final step is to solve for their distance, because that's what we're solving for, using the two ordered pairs that we have. The first one is 0, 2. And where do we get this? We simply get this from the y-intercept of the first equation. And then the second point is the one that we solve using line 3 and line 2, which is negative 2, 4. So you can assign this as your x1, y1, x2, y2. Distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. I say, so that is equal to negative 2 minus 0 squared plus 4 minus 2 squared. That gives us negative 2 minus 0 is negative 2 squared plus 4 minus 2 is 2 squared. That is 4. Even if it's a negative, when you square that, it still becomes positive, plus 4. So that is, since both are perfect square, you can express it as 4 times 2. So D is equal, because I want to move out 4 as a perfect square, and it's a product of two numbers. I can uh, move 4 outside, it becomes 2 square root of 2. So this is the distance between the equation here. Okay. So keep on, make sure you understand each step. Don't skip and don't go to the next step if you don't understand it, because it's kind of long process. Okay. Again, let's go back. First, from the given equation, if it's not in slope-intercept form, you have to write it in slope-intercept form like this one. Okay. So from those equations, we have line 1 and line 2. Okay. So our first step is to create an equation for line 3. And line 3 is related to line 1. The only difference is their slope, because their slopes are opposite reciprocal of each other. So we just get the opposite reciprocal of the slope, and that will be the slope of line 3. And then we take note of the first intersection, which is just the y-intercept of line 1. So it's positive 2, so therefore it's 0, positive 2. If it's minus 3, it's 0, minus 3. Always 0 and then the number for your y over here. Okay, so that is your first point. Now, we use line 3 and line 2 equation to come up with our second point. Okay, so we say y2 is equal to y3 because we are getting the intersection of the two. So assume that the two y's are the same. So y2 is equal to negative 1/3 x minus 4. And then y3 is equal to 3x plus 2. Since we have a denominator of 3, we need to eliminate the denominator by multiplying 3 to all the terms on the left and on the right side. So one by one, since there's a denominator 3, it crossed out. So 3 times negative 1/3 x is just negative x. 3 times negative 14 over 3 is just negative 14, because the denominator was crossed out of this 3 outside. And now here, there's no denominator, so you need to multiply them. 3 times 3x is 9x. 3 times 2 is 6. So you have negative x minus 14 equals 9x plus 6. We combined like terms, so we eliminate the 9x here by putting minus, by subtracting 9x on both sides. We eliminate the negative 14 by adding 14 on both sides. And that gives us negative x minus 9x is negative 10x. 6 plus 14 is 20. Divide both sides with negative 10, x is equals to negative 2. After having the value of the x, you will solve for the value of the y by replacing your x to either, again, to either your second or your third. Only to the second or to the third, because we're dealing with line 2 and line y over here. So we choose to replace it on the third equation. So y, it will give you the same y. Okay. If this is correct, it will give you the same y whether you choose a third or the second equation. So that gives us y equals 3 times negative 2 plus 2, negative 6 plus 2 is positive 4. Okay. Oh, this is negative 4. Sorry. Negative 4. So space to check. So negative 4. Where is it? Does it affect? Oh, it affects. This is 6. Oh, this is negative 6 squared. So this is 36. This is 440. That's 40. So square root of 4 times 10. 4 is a perfect square. So D is 2 square root of 10. That's the thing we have. Very good. And then we have now the final answer. Okay, so I hope you understand the process, and then try to do the classwork and practice. Please attend the Zoom discussion later so we'll clarify your confusion on the process that we have.